All right, welcome everybody. We'll get started in just a moment. Thank you for joining. As you are taking your seat, getting comfortable, please make sure you get familiar with the Q&A. You'll be placed in silence mode. And the questions, as you hear the speakers, you can address them to the individual speaker in the Q&A. We'll get started in 1 minute. All right, welcome everybody. Welcome to today's virtual conference, Securing the ICS Supply Chain. I'm Lucian Fogoros, and I'm the co-founder of IoT World. On behalf of the speakers, our company, and distinguished attendees, thank you for joining. We will monitor the social channels, so feel free to post your question in Twitter or LinkedIn, and leveraging the hashtag @dolus_ICS. I'd like to introduce our moderator for today's virtual conference, Greg Orloff. Greg, welcome.
Thank you, Lucian. Good morning, good afternoon, and good evening, everyone. Once again, thank you for joining us today. Now, before we dive into today's material, please allow me to give some of you who are joining us for the first time a little bit of background. IoT World is a digital media publication that covers the economic and technological implications of the transformation taking place as industrial IoT proliferates throughout the enterprise. IoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the industrial Internet of Things. Analytica's 2020 report ranked IoT World as the #1 global brand for industrial IoT. IoT World was also recently ranked by Keycore Analytics as the #1 global influencer on several topics that include industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. Additionally, Smart Cities has been in the top 5 positions for the past couple of years. Our mission is to help companies create a culture of innovation and connect the smarts, industrial technology, manufacturing, sensors, and the CXO decision makers that seek these solutions. Today, we're joined by representatives from Archer Security Group, Adolus, OSI Soft, and Schneider Electric that are poised to provide keen insights into the importance of securing the ICS supply chain. In these presentations and Q&A, we will discuss how securing ICS software supply chains is becoming increasingly urgent. Attackers, including criminal and state-sponsored groups, are turning their attention to the ICS supply chain as a fertile ground for exploitation. Critical industries are starting to devote serious resources towards the problem, and regulators are stepping in, such as in the power industry, where the supply chain regulations, such as NERC CIP 13, are taking effect this month. And with mounting attacks on the medical industry during COVID-19, new regulatory pressures are inevitable. Securing ICS supply chains is a complex undertaking, and we will highlight some key issues and limitations of currently available technologies, as well as solutions for safeguarding against attacks. Key topics of what we're going to cover today include threat actor techniques and tactics, product vulnerabilities, proven successful security architectures, specific threat examples, and a framework funded by the Department of Homeland Security to safeguard against ICS supply chain attack, how to satisfy regulatory requirements like NERC CIP 13 without introducing onerous or error-prone processes, capabilities including counterfeit firmware detection, mystery subcomponent detection, version validation, certificate chain validation, and detection of blacklisted software will be covered. We'll also walk through an end-user experience using FACT, Framework for Analysis and Coordinated Trust, as a software supplier to critical infrastructure operators. I'd like to kick off our session today by introducing Mr. Patrick Miller, Managing Partner at Archer Security Group. Patrick, the floor is yours. I think you're muted. Actually, you may want to just take it off of mute there.
There we go.
All right.
All right. Good morning. Okay. Fantastic. Securing the supply chain for ICS and IIoT. Great topics today. This is going to be an excellent conference, and I'm really looking forward to this panel discussion with everybody on the list. Really good lineup. So we're not going to dwell on this slide. Why should you listen to me? I've done a lot of stuff, and in theory, I've done a lot of work in this space. All right. So let's first talk about the history on the supply chain security side of things. What got us where we are is a whole mix of crazy things like, geopolitical issues, wars, but really what's driven a lot of it, at least in our current situation, is the market. It's increasingly difficult to buy a single product, especially a digital product that is sourced from one country, all of the components front to back. I would argue that it is impossible, right? Unless you're in certain countries like China, where all of it is made. So the global supplier construct and the global purchaser construct has kind of gotten us to where we are now, where it is really a big global mix of things and components and software written all over the place over time. So it's not an easy problem to deconstruct. Some of the bigger influences we've got currently, things like nationalism, balkanization, of course, which is kind of that separation of countries at their boundaries for their products and their networks. A lot of politics involved, and fence posts. These things just kind of naturally happen over time. They go up, they go down. You make enemies, you make friends. It's a standard ebb and flow of not just human relationships, but country and cultural relationships. The hardware and software that we currently use is profoundly complex in comparison to what it used to be. We have embedded things inside embedded things inside embedded things, where we're probably at the place where we've forgotten what we originally did. And the embeddedness is frankly so challenging to try to wrap our head around. I think it's going to be difficult to really run that one all the way to the end. The availability and opportunity of access to the product line, the supply chain, it's everywhere. So you have to deal with things from, especially for digital products, if it's a hardware component, one of the more difficult ones is, all of the sourcing, all of the firmware and other embedded software components, even the courier, right? Who handled it on the way. So the availability or access to your product before you get your hands on it is very difficult to manage. And of course, the big question is, what if bad things happen, to critical stuff, right? Well, someone think of the children. These are really important, really expensive pieces of equipment, and we don't want bad things to happen to them. Well, right, and frankly, no one does. I mean, anybody that is using this equipment, regardless of your culture or your government or your religion or your location, no one wants bad things to happen to their important things. So it goes without saying that infrastructure stuff, especially like IIoT, that's important to pretty much everybody. The goal for supply chain really is it's often things like theft, control, sabotage, destruction. It's not a nuisance style threat. It's usually, in most cases, fairly exigent, right? It's either destruction of equipment, sabotage of that equipment, or theft on a large scale of some very important things. Now, the concerns I want everyone to think about are not just about security, because we always talk about supply chain security as though that is really the end goal. There's a lot of that goes beyond that, because security is more of a capstone on a bunch of other stuff like quality and safety and economics. It's one component that adds a bit of assurance to those other areas where you already need high assurance. So who is using supply chain attacks? Who does this, right? Who actually, exercises a supply chain attack? It's these people. It's these nation states, non-governmental organizations, terrorist organizations, organized crime, or your well-funded competitors. This story is essentially someone who's got a lot more resources than you do in most cases is the party who does this. This is not an easy thing to do. If supply chain attacks were easy, everyone would do them all the time. That's kind of we'll get to the point here in a minute about there are other things that are actually easier. So why would you even want to use a supply chain attack? They're difficult to execute. You've got to get it right. It's got to execute like you want, and usually only under the circumstances you want it to execute. That can be challenging, especially if the product might or might not go into different environments. It has a high error potential. Again, if if it somehow goes off early, it risks early detection, or it may cause more damage than originally expected, or not enough damage, right? It takes a lot of effort to do this. So, picking any one of the attacks that we've seen as of late for the supply chain stuff, whether it's centrifuges or anything else, it takes a lot of effort to get the execution of that to work perfectly. So you've got to buy a lot of equipment or borrow a lot of equipment or test on other environments. This isn't something you can just kind of do in a vacuum without testing, without a lot of effort, without a lot of input. And there are a lot of other things that are easier to do than supply chain attacks. I mean, everything from reused passwords, just bad passwords, millions of unpatched systems on the internet, malware, ransomware, phishing, social engineering is profoundly easy. And if you wanted, you could probably spend less money and still get a 0-day, and others. There's a long, long, long list of things that are far easier to do than a supply chain attack. Well, they do it because it works. At the end of the day, once you put that much time and effort into it, it can be very effective. It can be surgically targeted to execute exactly what you want when you want it. Again, it takes a lot of effort to make that happen, but it can do that. It's often difficult to detect until it gets to that state, right? Until it does what it's supposed to do. Assuming you did it right and it doesn't show itself early and get detected, then it will be likely hard to see until it's executing. In most cases, given what we have in terms of our market right now, the degree of supply chain security it could be better, right? It's not great. We've left it as an afterthought. It's just that we've been innovating far faster than we've been trying to secure the supply chain, which isn't necessarily a bad thing. Things kind of happen in flows. It'll get there. But it's often overlooked or deemed unlikely. It's just not one of those things that people put up there on the high probability scenarios. They're difficult to get 100% coverage. It's hard to get everything that you want with a supply chain attack. You're likely going to get most of what you want, but it gets close. And then, of course, it's challenging to get attribution on some of these things. It can be very difficult to figure out who did it and why. It can be easier in other areas, right? With a lot of things like malware, ransomware, it can be much easier to deconstruct. So what can you do about it, right? I mean, if it's this big daunting problem that is done from well-resourced parties, what do you do, right? Do you just throw your arms up? Well, let's talk about some of the approaches that we're currently looking at. Focusing on buying only trusted products and services, and trusted is in quotes because really it comes down to what is trust, right? I mean, is it just a location? Is it a person? Is it a company? Is it a specific party? Is it a specific cultural mindset? Who, where, where does this really exist, and where is it? Where does that only exist, right? And how do you get that trust? I mean, is it something that you've earned over time? Did you buy in? Did you, have some sort of reputation or reputability score from an outside party? And is that trust transitive? For example, is it, just because you are part of another group like the Five Eyes, for example, does that mean you're trusted? And then again, how much is assurance how much assurance is enough? Where do you draw the line? How deep do you go? I mean, how much do you need to actually get enough trust to qualify? And then how long does that last? I mean, there are some nations that are not friends today that were friends 5 years ago, maybe 10 years ago. So it depends. And when we buy infrastructure products, I'm thinking of things like, electric transformers. They're going to last 30, 40, 50, 60, 70 years in some cases. So those are difficult to look at things in terms of a span of time as well for trust, because it's not just a one and done. So some of the possible solutions that are out there now, and there are more than are on this slide, obviously. I just picked some of the more, I guess, some that are gaining a little more steam or have more impetus behind them. Of course, there's this thing about, make it yourself, right? Well, if you could do that, I think it would be done already. In today's market, that's virtually impossible. As I mentioned earlier, you can't really build a digital thing today and have all of the components made by hand from scratch. I'm sorry, you can, but it's excessive in terms of the cost and the resources to do so. So if you did, it would not be scalable and it would not be cost effective to purchase for anyone. Things like software bill of materials. There's a lot of discussion around this, and I think that's great. Software bill of materials is a fantastic option. It's difficult to get. Understand that the juice may not be worth the squeeze to get to the endpoint on that, but at least getting some depth in there is certainly a great idea. There's talk of independent certification bodies. That's also not a bad idea. There's questions around who certifies the certifier, and are there standards maintained with innovation? And it can also create, there are some that argue that it can stifle innovation. I think it depends on how it's balanced. So there are some options there as well. And there's certainly some good options there. Transparency centers are a new one that I'm seeing, and I think they could probably get a lot more attention. If an organization is willing to open up a transparency center, and maybe even the transparency center is certified by an independent certification body for being totally transparent or transparent enough, then you could go view what you need to, and you could gain access to the transparency to get your assurance up. This could be done by any party, that kind of thing. So there are some options there. I think that can be explored a lot more than it currently is. Self-vetting, which of course is you just doing your own research. I think the challenge there is you don't know what you don't know, and you're left with whatever resources you have at your fingertips up against possibly some organizations that are far outmatched in comparison to resources that you've got. They're far more resourced than you are. Herd immunity, public, crowdsourced, external vetting. This one is actually really, it's easier out of all of them. Because everybody is, if we at least all kind of use some of the same approaches or the same tool sets, and follow some of the similar paths, we end up with similar results, right? And it can make the problem more of bite-sized approaches for many versus just one or two. Of course, development standards, that makes sense, right? I mean, why not develop according to specific standards and then get certified against those standards? And things like, regulation, executive orders, and saber rattling. I think this is a necessary evil, but it probably has the least amount of benefit. And I say that as a recovering regulator myself in the electric sector, and having written some standards and currently on some guidance working groups for the regulations. This one is something you definitely do, but it sets the minimum bar. It's basically, you must be this tall to ride the ride. It is by no means going to be a full solution for any of these. So the problem with this is typically these can be done, if they're not done methodically, slowly, and organically, they end up being quick, and quick regulation is always bad regulation. And they can often come with political motivations with things like executive orders and saber rattling. So let's go down the rabbit hole. How deep do you go? What do you need for assurance? Is it just country of origin? And if it's like made in the USA, which of course is what USA wants, what if it is assembled in the USA? What if it is, does that what made means? Because all the parts we're probably going to buy from other places, and then we're just going to put it together here. So does made in mean assembled in? And the people that, the country of origin, maybe it's a country that we trust, but is that a country that we're going to trust for the lifespan of that product, as I mentioned earlier? Hardware components and subcomponents, how many little things go into a piece of digital equipment today? Everything from, the printed circuit board and everything that is stacked on top of it, all of the software components, firmware components, BIOS, compilers, libraries, drivers, DLLs, microcode, all that stuff. I mean, how deep do you really want to go to gain a level of assurance? And then who developed it, right? Do we trust the developers that wrote it, the technicians that worked on it, or the installers that put it in, the integrators? What about the delivery person, right? Who carried it from point A to point B, or anywhere along that chain? How do you really want to get to a level of assurance on this? We're going to have to draw a line somewhere, because at the end of the day, it's going to come down to cost. Can you afford to get the assurance that you want and still buy those products or use those products? So let's talk about some costs, and we'll talk about some impacts for your buyers. If you are buying these products, you're likely going to have to change your procurement and purchasing practices, because you can't just buy from anywhere. You're going to have to show that you did some diligence around how you buy and where you bought from specific vendors. You might have to use there's likely going to be an include list and an exclude list of these are the bad vendors and these are the good vendors, and the vendors will be jockeying for position to get on those lists. And that's going to be challenging for you as a buyer, as a purchaser. You can't just get the lowest cost and most effective. You will have to go through a bunch of flaming hoops to get what you want. So the security teams on the inside of these buying organizations, you're likely going to have to review or assess your vendor security practices. And unfortunately, you're at least going to have to ask some questions. And there's a flip side of this. We're talking about the vendor impacts, is they're going to have to answer these questions or provide some transparency. And then, of course, in incident response, what if your product is now on the naughty list, right? Or some component of your product is on the naughty list. What do you do? That usually has some sense of incident response from an organization, your response to what that means to you. Project management, right? Your costs are going to go up because your project timeline is probably going to extend because you can't just go out and buy what you want to buy when you want to buy it. So things are likely going to change in terms of your project lifecycle internally for doing big infrastructure things. Installation and maintenance, obviously, this is key, right? Can you use, integrators that you can't vet, right? Can you use developers that you can't vet? Can you maintain these things with people that aren't vetted, right? Or that aren't approved because they're touching sensitive equipment? What could they do? Of course, the regulatory overhead, there's a lot of things like audit and compliance that come with this. That comes with some significant weight, just from an administrative overhead perspective, right? Of course, risk and insurance, in the event that you want to do risky things, that's going to affect your profile. In the event that you don't want to do risky things, you're going to have to demonstrate that you're not. Either way, it comes with a cost to you. At the end of the day, it is a higher cost over the entire life cycle of product or service for everything that you buy. Once you enter into the supply chain security space, costs go up. Some vendor impacts. Let's talk about the flip side of this. There are definitely a bunch of competing international standards. And if you're a multinational organization and you sell across the world, which all of our vendors do, you have to deal with pretty much, whose flavor of the day, which country's ideas and perspectives, and how do you match all of them, right? I mean, it's difficult to like put them all up there in a big spreadsheet and make like a high watermark and match that and satisfy everything. And it's impossible. Of course, there's the unique customer assessment requests because everybody is now asking all their vendors to provide them with the nth degree of minutia about every single aspect of their product. They may or may not know that. And it may be very difficult for them to get all that information. And, honestly, even if you had that information, would you know what to do with all that information, right? I mean, how do you assess the mountain of data they come back with if they come back with it? So that one is a bit challenging. I've talked to several vendors that are just drowning in these insane requests from customers for, the level of depth you go to get this some assurance. I mean, how much assurance is enough? Of course, the specific contract language, almost everybody wants a new terms and conditions section for their contracts, which means the legal sides on both ends of this equation are just basically making money. Just to be honest, there's a lot of money to be made. So as these things change, the terms and conditions, when it gets into the legal side of things, costs go up as well. You may only be able as a vendor to produce certain products in specific locations for specific markets. The brick and mortar and infrastructure manufacturing cost for your and development cost for your product goes up. So the cost goes up to the buyer accordingly. And then specific production components. You may or may not, you may be only be able to use certain things, right? You may not be able to use other things that you've done in the past, which requires new testing and integration, especially if this is in the industrial side. The level of assurance of reliability of that product's got to go up. So when you bring something new in, all of that testing and rigor has to be put into that from the start. It can't just be, modular and popped into place like Legos. Of course, there's market constraint sources for everything. As everybody rushes into the supply chain world, the resources to actually do this work are constrained. So their costs go up. It's a supply and demand seesaw that it's economics 101. Of course, audit and compliance, the vendors have to go through audits and compliance as well, whether they're trying to compete to some quality standard or manufacturing standard or anything else that comes with this, their audit and compliance costs go up. At the end of the day, again, costs go up. Additional vendor service impacts, maybe you're just a service organization. Your personnel have to get vetted, lots of training, certification. And then once you've done all of that and company X, your competitor wants them and they pay, an extra $100, they're going to steal your staff. Well, that's going to be a challenge as well because retaining them is going to be difficult. Things like access management. Are you equipped to instantly remove and grant access, for example, to your entire supply chain components for all of the people that you have? Think of it from a development, like a software development standpoint. In some cases, that's yes. In some cases, that's no. And again, audit and compliance, because this is going to be necessary to demonstrate your diligence that you're doing this. Costs go up. At the end of the day, I think I made my point. The part that comes along with this is the subtitle. As those costs go up, everyone behaves accordingly. Because at some point, you're not going to be able to buy the products that you want. So you will make decisions at that point on what to do about that. Manufacturers will have to make decisions on what they can charge. So, you know, other product lines might be constrained. You may stop making one thing to make another thing because it's more profitable. So everyone is going to have to react accordingly to all of these shifting costs and behaviors and practices. So some stories, what I've seen in the field. This is the big one. Everything is strained. The relationships between internal organization units, your vendors and the buyers, everybody is basically really cranky about this. No one likes it. The governments are angry. Everybody's frustrated, and it stinks. We got to get better. It's going to take everybody, frankly, just being honest about this and compromising. I hate to say that, but we're all going to have to come to some middle ground. It can't just be push it all off on the vendor, because they're going to say, well, if we're going to take all that risk on, you're going to pay for it. So you're going to pay for it one way or another. You might as well put some skin in the game on the front end of this. So let's find a happy medium in there somewhere and take down some of this strain and frustration and noise. And we're going to have to work together to get to a more secure place. So enough of the Teflon and finger pointing and forgetting that, you know, you do have responsibility in this. We have to figure out things like the predictive purchasing. Let's, you know, if one vendor is now something company non grata because they've done something, they should have a chance to redeem themselves at some point, because it may or may not be, you know, an accident, or it may be intentional. Until use Hanlon's razor. It's probably not malice. It's probably something else. Because vendors are really out there to necessarily make money. They're a business. They're not trying to just shaft you from a national security standpoint. And they're often willing to do what it takes to make sure they can still sell their products. And again, security professionals are mixed on the value of this when there are so many other things to do. I hear from security professionals all the time. They've got, you know, unpatched systems on the internet. They've got bad passwords. They've got incredibly, you know, monumental, severe impact issues in their organizations. And they're thinking, I got to worry about this now, this low probability thing, this high cost, high impact thing, versus, you know, trying to get my stuff patched. So they're really freaked out about the fact that it's sucking all their resources away and basically bleeding them dry for something they believe has mixed, or in some cases even lower value. And as I mentioned, how far do you really want to go? The challenge with this is, where you stopped, you're probably going to have to justify why you stopped where you did to somebody, whether it's a regulator or an insurance firm or your board. Somewhere you're going to have to decide what your line is and why, and provide some solid justification for that. So what really works, we've seen these things are actually working right now. And I've seen a lot of organizations and a lot of different industries. First of all, you can't do nothing. You're going to have to do something, right? Start somewhere, do something. Start small, you know, pick some bite-sized pieces and move forward. Just start gaining some traction, gaining some understanding, learn the language, right? Learn the lexicon so you're speaking the right words. And you can't transfer all of the risk to anyone. I don't care if it's an insurance firm or a vendor. You're going to have to put some skin in this and do some work yourself. Much of that heavy lifting, if you did it yourself, believe it or not, the total cost of ownership for either hardware or software, it's going to go up. So if you do much of this yourself, that cost goes down. And it's an internal piece that you probably already have resources for. And it would be easier in some cases to just get these skills up front, because products are going to change, vendors are going to change. But if you have those skill sets internally, that doesn't. You get to reuse that and repurpose that forever. Okay. So treat it like anything else in your security program, right? It's just another risk. It's one more thing in our all hazards perspectives. Don't create dependencies you can't do manually, right? These are some simple fundamentals you should be doing anyway that go a long way in your supply chain space. Validate your sources. If you're not doing that, why? Why weren't you doing that already? Monitor your internal and external networks for issues. If there were a supply chain attack on one of your critical things and it was communicating outbound and you don't know that, shame on you. That's your fault, not your vendors. Practice incident response like it's game day. Something, sometime, somewhere is going to happen. And if you're not prepared for it, well, again, you're going to have a really bad day. So practice like it's game day, and then lather, rinse, repeat. Do it over again. Pick framework. There's a bunch of them. They're all great. I don't care which one you want. Grab one, try it on for size. If you don't like it, pick another one. Go to their dressing room, try a few out. This is important because if you don't follow something, you're going to miss something, right? And it's much harder to justify why you stopped where you did. So these are some tools. Pick one. They're all great. Just use something to help you kind of guide you down this path. Contact me if you want. I've got a lot more noise to rant about this if you ever want to hear it.
Wow, thank you, Patrick. From a personal side, I appreciate the perspective around standards, certification, accreditation, and regulation. I mean, that whole world and quagmire, not to be a negative in connotation, but my takeaway resonating with me was quick regulation always results in bad regulation. So
Yeah, absolutely.
Consensus takes time, right? So you got to
Yeah.
build that in the front. No, fantastic. Thank you for sharing. So moving on, next we have Megan Sanford, and Megan is the VP and Chief Product Security Officer for Energy Management at Schneider Electric. Over to you, Megan. The floor is yours.
Great. Thank you, Greg, and happy to be here today with you all. Man, I have to say, Patrick Miller, he's a hard act to follow. I have to say that in my day, I've sat in on at least one or two presentations or trainings on ICS supply chain security, and I don't know that anyone successfully kind of gave a crash course the way that Patrick did. So I'll even have to go back and take a look at all the points that Patrick brought up. So great job, Patrick, and thank you for that. Next slide. So like Patrick, I'm not going to read you my life story or my biography here, but the bottom line is that I have over 15 years in security. I work for Schneider Electric. Prior to being at Schneider, I was at Rockwell Automation as well as GE, and I led critical infrastructure protection for two Virginia governors. So I have a good amount of experience both on kind of the traditional critical infrastructure protection, guns, guards, gates, traditional physical security experience, as well as experience on the cyber and the control system side as well. Really love what I do. I'm passionate and I volunteer in a number of different areas. I'm the founder of the ICS for ICS, community-driven effort around having common lexicons and common frameworks around incident response in the space. I'm also the program chair for RSA this year for the Secure All Your Things track. If you're interested in submitting, we definitely want to hear from you. I've participated in InfraGard, Military Operations Research Society, was on the board of Trusted Computing Group, and I currently also volunteer with Department of Homeland Security for their Cyber and Infrastructure Security Working Group. And again, I chair kind of the incident management piece of that. But at my heart of hearts, I'm kind of at the intersection between industrial control system security, emergency management, risk analysis, physical security, all of those things. Really love what I do. And if you ever want to reach out or talk about any of these things, follow me on LinkedIn, send me a note, and I'll get back to you. Next slide. So as I mentioned, I'm the Vice President, Chief Product Security Officer for Schneider Electric's energy management business. Fundamentally, Schneider Electric, we're a global company that sells products into the energy sector, both from energy product standpoint as well as many digital offers as well. At the end of the day, we believe that life is on when energy is on, and we believe that providing energy to all countries and all people is a basic global fundamental human right. Next slide. So just a snapshot, I'm not going to spend too much time on this, but as I mentioned, we are a global company. If you look at our presence, we're very globally balanced. We have interest in pretty much serving the globe in its full capacity. We have over 135,000 employees. 41% of our revenues are in new economies, and in 2019 we did 27.2 billion, with 5% of revenues being devoted to R&D. So that gives you a good flavor for who we are, what we're doing, and what we're interested in serving to really advance energy and advance the opportunities for everyone that lives in the world. Next slide. So the perspective that I'm going to be speaking with you all today about is really more from the product development and the kind of encompassing product lifecycle stance on how we view and how we care about supply chain security. As Patrick mentioned on one of his last slides, it does and it should all start with the controls framework to help you define your initial security requirements. So for many companies that I've worked with, that's been both NERC requirements as well as requirements from IEC 62443 4-1. So 4-1 is really kind of a comprehensive kind of cradle to grave aspect on how companies should think about producing products, testing products, sourcing components from products, all the way through to the final disposition and destruction of that product after it's lived in a customer environment and they no longer have a use for it, in fact. So wing to wing, that's what 4-1 covers. With that, you have to take into account the very early onset of setting security objectives and working with the suppliers that you have, providing you different components that, as Patrick had mentioned, ultimately are assembled and become the final product. When you're evaluating your suppliers, you too can use a similar controls framework approach and asking them, what does your secure development lifecycle look like? How are you testing your products? What open source components may be used within components that are then passed on to you that you need to know about so that you can properly disposition and manage those third-party components? When you go down that path, what you want to have in place, if you're a company that makes products, is a solid software bill of materials as well as hardware bill of materials. And the latest term that I've heard used in the space is kind of something that I think is meant to capture both, which is a digital bill of materials. Once you have your bill of materials, you can backtrace that to your suppliers and again, go through the assessment of those suppliers and begin to understand who is supplying you with what. And from a contractual standpoint, as well as a basic relationship standpoint, do you have faith in their security programs, their ability to make a secure product or component for you? And can you verify and validate that they have performed proper testing on those components prior to you basically inheriting that risk? Because you become responsible for that as well. And so one thing that vendors and other suppliers, I guess, of products and components can do is that you can perform your own product testing on components that you receive to ensure that there's, we talk about things like backdoors or really what's more likely is maybe even counterfeit product that is not built to spec or is not done properly, or it has, it's not built in a secure by design way. You can do your own pen testing to validate that what you have purchased is in fact exactly what you asked for. And when people talk about supply chain security, it seems to me that it's a very inflated term, but in the simplest sense of the concept, I say that supply chain security is your promise to your customers that what they are buying and what they are receiving is no more and nothing less than what they believe they have purchased, meaning that there's no additional functionality such as backdoors within the products. That supply chain security from the vendor perspective, in my opinion, really should be about your guarantee of standing behind a quality product, both from a security as well as a product safety standpoint. And so it doesn't necessarily have to be a politically charged conversation. I think really if we want to look in our heart of hearts, it simply should just be a conversation around producing a quality product in a repeatable and scalable fashion for all of your customers around the globe. And so once you have made that product and you have your relationships with your customers and you have your relationships with your suppliers, what you can do on the outbound side of supply chain, since much of what I've discussed with you all to date has been inbound supply chain and the way that products are made. On the outbound side, I've seen across industry, there are different tactics that can be employed, such as anti-tampering, as well as anti-counterfeiting protective measures. This can come in the form of geotagging of products while they're in shipment to the customer, as well as labeling and little things like that. Graphics on the product actually can play a pretty big role in giving your customers tools in their toolkit to identify if a product that they have received or they thought that they were purchasing from an authorized dealer of your product, that it is in fact a legitimate product from your company. I've seen many companies recently stand up campaigns around educating customers around what maybe counterfeit examples of their products look like. And I think that that's awesome. And we know that as vendors, the day that our products ship and leave our facilities and are inbound to our customers to the point that they're installed in the customer environment and carry out their life, that we have to do everything that we possibly can to help that product be as secure and as safe as possible throughout its lifetime of operation, and enabling a transparent and free flow of communication to your customer around potential issues that come up. That's everything going forward, because really you want to enable that customer or that integrator or whomever to protect that product in the way that is helping them and keeping them safe and secure, as well as protecting your own company from the fact that you want to maintain a reputation for producing safe, secure, and ultimately quality products. And so that two-way relationship, I think, is everything. And when we talk about supply chain, I don't, or at least I haven't in many cases seen that part emphasized as much as it probably can be. So if you remember anything from what I'm telling you today, definitely whomever you're buying products from, sign up to receive their notifications around security advisories, safety advisories. Have an open line of communication with your account managers, customer care, all of those things, so that your vendor is helping to serve you in the protection of that product while it's living in your environment. And then even afterwards around questions concerning proper disposal of the product, to make sure that it's truly disposed of and it's not being resold or anything like that back into a market. So that's really all I have, but if anyone has any questions, feel free to reach out to me. Love having healthy, non-emotional conversations around these topics. And again, really appreciate the time today.
Thank you, Megan. Great insights as always from Schneider and yourself, by all means. In a world of information overload, the emails coming from your suppliers are not the ones that you want to send to the spam folder. So if there's insights coming from those folks, those are the ones you want to tag in and make sure you're reading that in real time. So thank you again. We're going to take a short poll now. We have a question you should see popping up on your screen here. So I would invite everyone to go ahead and select your choice that makes the most sense for yourself. We're basically asking, which supply chain security controls are most urgent for you? So take a moment and go ahead and review this, make your selection. And while you're doing that, I'd like to bring on and introduce Eric Byers. And Eric is the CEO of Adolis. Eric, I'll turn it over to you to walk through the presentation and also show the poll results.
Great, thanks very much. It's a real pleasure to be here. And it's a real honor to follow two real industry experts like Patrick and Megan with so much experience out there. I'm going to be talking in a second about this poll, but I wanted to talk just initially about one of the intents behind this poll, and it's that as I've worked on this project for the last couple of years, I've really noticed that the supply chain problem is a really massive and sort of undefined problem often. So I wanted to get an idea, we wanted to get an idea of what is it that's really important to you, the viewer. So let's see if we can see, okay. There we go, there's our poll results, okay. And it looks like the winner, tracking new vulnerabilities in your software and subcomponents, looks like it's the #1 winner. Followed by authenticating new patches and software. So those look like what's really driving our audience right now. And so that'll be interesting to talk about over the next few minutes. All right, so with that, let's move on. And I'm going to try and get onto the next slide. Okay, great. So just to give you a little background, for the last 4 years, I've been working on a Department of Homeland Security project that eventually became called FACT, that is around what is needed for supply chain security for software and firmware and control systems. What has really been interesting about this whole thing is that it's not obvious. I mean, there's the obvious, or maybe it's more than what's obvious. Like there's the clear problem of somebody creating counterfeit software or injecting malicious software, and we've seen certainly examples of that, and I'll talk about it. But there's so much more as well. I'll give you one example. This is the clearest example of where supply chain problems can really occur. So you may have heard of Dragonfly. This happened in 2014. And this is a perfect example of exploiting that trust between suppliers and users. What happened is these cyber attackers went after vendors, 3 vendors, European vendors of industrial control system products. Not major ones, but not minor ones either. And what they did is they hacked their websites and replaced the legitimate software that was on those websites with Trojanized versions containing the malware called Havox. Now, we've taught our technicians to patch early and patch often. And so within a few days, technicians all over the world were downloading these software packages and, of course, installing them in their systems. And these packages, once they woke up, would go back and call home. So this is a perfect example of counterfeit software or modified software. It's one example of how you can see the supply chain being infected and then exploiting industrial control systems. What's particularly concerning to me about this was that it's really good return on investment for the bad guys. It wasn't simple to do, but they only had to attack 3 vendor websites. And the one company that I worked with quite extensively, we saw that over 270 companies had downloaded that software. And that, I'm assuming, is, a technician's not going to download the package separately for every single device they have in their plant or for all their plants. So you're looking at a real multiplier effect here. Again, it's great return on investment from a cyber attacker. They may be a little tricky, but you can get a lot of ground by just, say, attacking one vendor or attacking one package. Now, one of the things Patrick mentioned is all the ways that software and systems and checking the couriers, all the ways that systems get transferred from manufacturing to the customer is quite complex. And software is the same. I mean, it could be downloaded from the website. It could be passed by a CD or a DVD. It could be brought in by a consultant. And so we really need some mechanisms here of really validating software at the end point, at the point it's going to be installed. Now, sometimes it's not malicious. Sometimes it's just this whole question of what are the subcomponents. So a really great example is Gemalto. It's a license managing system. There was lots of news, and if you go on to vulnerability databases, you can look up Gemalto, but who knows they're running Gemalto? No supplier of software says, hey, we run Gemalto for license management. So you may be buying products from a vendor, but you don't even know you're running Gemalto. So this is where it's really important to understand those subcomponents. And sometimes those subcomponents are ones you don't want. We've had these recent issues of blacklisted software like Kaspersky, like Huawei, etc. And Kaspersky is a great example. It doesn't come in a box shrink wrapped. It can be a component or a subcomponent in a product that has a completely different vendor's name. So it's very important, again, we'll go back to that supply chain to understand where those subcomponents are coming from. It's all part of the subcomponent problem. And one of the things we learned too is version validation is really, really important. I don't have to get you to load malware if I can just get you to load old versions with big vulnerabilities. Now it's obvious, we probably shouldn't be running Windows XP anymore, but it's much less obvious if it's an industrial control device. If you're talking a particular version of a drive controller firmware package, who knows which ones were vulnerable and who isn't? I mean, you can find it out. And that's the challenge. You can find it out. How do you do that? It's a lot of work. Finally, I wanted to talk a little bit about code signing, because code signing and the most famous supply chain attack is Stuxnet. And code signing is great, but it won't fix everything. It can be misled or used in really, really nasty ways. And in fact, one of the things that we've started to notice is that the majority of well-signed software on the internet right now is malware. Why? Because it tends to be a free pass for attackers. So just because something is signed doesn't mean you should use it. What signing is really saying is who this came from. And so if it says it's been signed by Rockwell or Schneider or OSIsoft, that's one thing. If it's just signed, well, that might be signed by your local mafia. I mentioned that the information about vulnerabilities, the information about version control, it's all out there. It's available. But the trouble is that technicians typically dealing with thousands of devices, hundreds of vendors. There's hundreds of tools you can use for malware detection, vulnerability detection, version management. There's so many tools, some of them really, really good, some of them really, really expensive. There's also hundreds of databases that you can go look at. And this is a real challenge. How does the technician in the plant floor, in the substation, actually trust the software they're using? And the answer is, from our DHS research, is they just trust it and they don't bother checking. So asking them to check hundreds of databases or use tools is just not efficient. So this is what we learned out of the project, is that the complexity of this problem means that what we need is some way of coordinating all that information. And this is the intent behind FACT. It's a framework for analysis and coordinated trust. And it's basically an ecosystem for brokering information from as many different sources as possible about the firmware and software a company is using. Consider it a bit like a trust score for firmware, like a credit score. When you go to the bank and you want to borrow some money from the bank doesn't phone all the credit card companies. They don't phone all the other banks. They don't phone the department stores. No, they'll go to somebody like Equifax or Fair Isaac and ask for a one-page report on what your credit history is. And that's exactly what we need for firmware. We don't want to send people out and say, oh, you're going to learn some new firmware and you want to understand its supply chain. Why don't you go check all of these databases, check all of these companies that supply components. Otherwise, it becomes exactly what Patrick mentioned. It becomes expensive and onerous and just too complex. So the architecture is really simple. We start off working with the vendors and we give them a little agent that fingerprints their software and their components. And this goes back to that software bill of materials, and I'll talk a bit more about that in a second. That's really, really critical. So in effect, what we're doing is we're automatically building a software bill of materials for the vendors. And then we publish that software bill of materials into our cloud system, and then basically use that for analysis and going out and hunting and seeing what is known about those components. Are any blacklisted? Are any of those components listed as potential malware, etc.? And out of that gets a score that asset owners or consultants can use. Now, I want to be really clear about the importance of understanding components, and what a software bill of materials is, or whether you call it a digital bill of materials, or is literally a list of what software subcomponents are in a package and who made them and what are their characteristics. So take a typical PLC upgrade package. It's going to have lots and lots of components in there. Some of them will be Windows components for loading. Some of them will be firmware. Some of them will be drivers. Some of them will be communications drivers. So all of these components will be included in that bundle that you will get as a user and as a vendor you will be creating. What's really important is to understand those relationships. So if there's another upgrade that comes out a little while later, and maybe the RTOS communications drivers are exactly the same, but what's changed is the binary firmware, or the firmware binaries, that's important to know, to be able to understand. So if you have a problem later and you're trying to understand what those relationships, for example, something like Ripple 20 comes out, which was a vulnerability in the communication stack, you understand what it impacts. It's not just impacting one package, it's impacting a whole family of packages, and often not just within one vendor that you use, but across multiple vendors. So I want to stress just how important it is to be able to build these trees. I also want to point out that the intent of building a database of trees like this is not just for web demonstration. It's really to be able to be automated so that you can collect data from the plant floor, from laptops, from servers, and then understand what subcomponents are being used in a facility. I'll give you a couple examples are clearer to understand if you look at it from a web point of view, but could be done again as a submission automatically from, say, file detection, etc. And that is, take a technician who has been told to install this binary. Now, this binary is unsigned because that's the nature of most binaries. He knows it's PLC firmware. If he looks at it and tries to open it up or try and search for it, he'll find very, very little information. But by building a supply chain bill of materials, we can actually, whoops, jumped a little bit. We can actually see that this was originally contained in the installer packages that Rockwell shipped, and those were properly signed. So again, you can see the value of something like a bill of materials here. Here's a different example. Here's a almost identical looking firmware bundle with the, pretty much the same name, but it was never part of an official upgrade package. So that makes it pretty suspicious. It's probably counterfeit. We also mentioned certificate problems. And again, if you're looking at all the components, you can look at the certificate chains and you can see that the chains, while well signed, actually are signed by somebody that you don't want to be buying software from. We mentioned vulnerabilities, and I noticed most of you are concerned mostly about vulnerabilities. Take this Protection and Control Manager package, and it has a very low score. And the reason is, if you start to look at that tree, and there's the bill of materials right there, you can see that there is a vulnerable third-party module hidden in it from a company called SafeNet. Now, as a user, you wouldn't even know that you had SafeNet product on your plant floor. It's only by building and creating those bill of materials. And there's some details. And then finally, version control. One of the things that have been great working with the vendors is the vendors have been marking their packages and saying, hey, this product is obsolete. Patrick mentioned cost, and while there is some efforts and cost, you can use FACT for free right now. So give it a shot. There's the link, and just go and play with it and try it out and give us feedback. We're really interested in making this sort of something the whole industry can use. Anyway, at that point, I'm going to hand this back to our next speaker.
Thank you, Eric. Definitely take Eric up on that invitation to go give the website a try. So we're going to bring out our next speaker now, geared up for us. So the floor is now yours, Brian.
Hello, everyone. I'm Brian Owen. I'm with OSI Soft, a security architect and a professional engineer. I've really enjoyed the lineup this morning, and by now you probably see how complicated supply chain security is. At OSI Soft, we've been working on supply chain security for quite a while. A little bit about me. I think I'll skip over this and just go right to our company. We believe supply chain security is important because, like many of the suppliers in the ICS community, our products are used widely across many critical infrastructure sectors. And the supply chain is complicated, especially by OEM relationships and so forth. So it's not just where our software is used directly, but it's also used in OEM products. So this is just a understatement of where our technology is used and how important it is to society. So as a professional engineer, what I'm shooting for is personally and as a contributor to our company is to improve the welfare of relay society and everyone in general. If we can do that and also generate profit, that's great. But part of being a professional engineer is that profit isn't the only thing that drives what we do. So, like Megan said, keeping the lights on, or today with COVID, we really need to help the world. So that's what engineers do. And when I look at supply chain security and this kind of problem, it's a perfect place for engineers to contribute. So let's drill into it a little bit. And this paper from Danzig from US Navy is maybe a little bit old, but I really like it. Not just the symbology of the apple here, which from a technology person, you can overload that many different ways. But the idea that it's a dual-edged sword with technology. We depend on it. It's brought so many awesome innovations and helped so many people around the world. But at the same time, is it slowly poisoning us? And is it bad fruit? I don't know about you. I'm pretty good at picking apples, but I'm not very good at watermelons for whatever reason. It's 50-50 with me. They sometimes are very, very sour. So with software and technology, you can't really, it's more like the watermelon fruit. It's very hard to see what's inside this fruit and just how toxic is it. Now, Patrick Miller allowed me to say one of his taglines here. Patrick likes to say that, hey, it's all T. It's not about IT. It's not about OT anymore. It's all T. And I agree with that. And this slide brought it home for me. I saw it maybe back in the evil maiden days of a vulnerability that was so low on the stack, it just affected so many people. And that's what we're trying to say here. With supply chain systems on a chip, we're at a point now where these issues affect everything. It's not just one part of the world. It's not just one supplier. As Eric showed in his graphs, when issues come up in technology, to chase it down, it's a massive graph problem. And at the hardware layer in particular, there are some good solutions. One of the first, before I get to that, the other part of that is if we don't pay attention to this, we've had researchers show us what will happen. This internet chemotherapy project, as it was otherwise known as BrickerBot, just shows how quickly things can be destroyed. And it's, we've seen examples that have affected things closer to home from NotPetya and the other internet worms that have recently struck just a few years ago. One of those, in fact, was an auto updater from, who would have guessed, a tax software could infiltrate all the way down into major shipping suppliers and manufacturers of food and beverages and so forth. So this is a real threat. Supply chain does need to be addressed. And on the hardware side, there's been some great research and brilliant minds put to this problem. I've picked three of my favorites out here, but when you look at the intersection of what all this research says is on the hardware side, we have to get to a hardware root of trust, as it's just table stakes. So when you're out shopping for your devices, when you're building your company standards, please consider at least that level of granularity. Does this device offer a hardware root of trust or not? And there will be times when you just simply need, for cost reasons, to go with the lowest possible cost. That little TPM chip just, the quarter it adds to manufacturing was just too much. I say in jest. But the idea is that for any chance at all for security assurance, we need to have a hardware-based foundation. Now, certainly there's a lot that can be done underneath the hardware. That is not my particular area of expertise, and I will leave that to others. But once we get that hardware root of trust, the software has a chance. And what do I mean by that? So as an engineer, I'm biased to putting that first. When IoT devices, ICS devices are from the inception of the use case, we need to start thinking about what could go horribly wrong. And I'm sorry to bring it up in this context, but the tragedy of the 737 MAX comes to mind. We really need to be thinking about things at the design time, and why that relied on a single angle of attack sensor just now in hindsight was a horrible mistake, and that was in this category of engineering. And we often forget in supply chain security that those kind of engineering decisions are also in scope of supply chain security. We have to have confidence that what is being purchased, what's being used in our critical infrastructures was actually fit for purpose. It was designed properly and is being used as designed. So once in the design phase, we understand what can go wrong in our threat models and so forth, and we decide how all that's going to be mitigated. The final step is being sure everyone knows, right? And sometimes in the engineering design, we say, well, this is safe to use so long as you have this, this kind of an environment, right? So if that's not well communicated, we can have a real fallout. And one of my favorite taxonomies to address this number one is actually from EPRI. EPRI came out with a technical assessment methodology that does a great job of finally communicating, what was this intended environment for a piece of equipment. So now number two, and this is where FACT comes in, is this bit about transparency. Patrick Miller mentioned transparency centers, and I absolutely love the concept of what that could mean as perhaps a more appropriate and efficient way to bring some assurance. It's not the total answer, but I think it is a part of the puzzle that deserves more investigation for sure. Some of the bullets on here include, we've already talked about software bill of materials, but manufacturer usage description is a great one. This is a standard that will open up automation. When you get a device, what actual ports need to be open? How does this device work in a nice standardized way to communicate that? And analysis frameworks, and this is really where I think FACT shines. And we're seeing emergence of, even in the regulatory space, that analysis will play a big part. The new labeling standard that came out of Singapore puts layer 3 of their assurance level is based on binary analysis, which I think is great. FACT is a perfect foundation for something like that. All right. Where'd it go? So what I wanted to talk about is our experience specifically using the FACT system. And we've been using FACT at OSIsoft for at least 2 years, maybe longer, really inception of the project. And the inception comes back to, I had this problem. We serve some sectors that are, critical, as I showed earlier, and some sectors are, let's just say, farther along in their journey than others. In particular, the nuclear sector got the word out post 2012 or so that all software must be validated when they receive it, and that was actually one of the high bars in Eric's poll, and that led to this problem of, well, how can we really do that effectively across the ecosystem? And I was really disappointed with this idea that the best the industry could do is post a hash alongside the file that you're downloading. When we think about Havex, if they could change the file that you're downloading from the website, they can change the hash code that goes along with it. And it just didn't seem very good assurance to me, and we needed a better way. Now, we've been signing our software to OSI Soft for decades. Required for the ecosystem we do, but our signing certificate, we needed a trust anchor for it somewhere. And I asked around the government and everywhere I could find, where can I post these hashes for our signing certs? And there just wasn't any place. And when we got talking with the team at Adolis and Eric and so forth, they said, hey, we can do that, in fact. And that got me very interested in using FACT. So the very first thing we can do is any customer that wants to validate the software that they download from us, there is an independent place where they can go, just test a link on the FACT system and say, yep, this is exactly the software that was intended to be. The hashes are all there, the certificate chains are all there, and it really solved a big pain point for us. And this pain point's really an important one, because I believe it is the first step in a curated set of software for the ICS environment. FACT is purpose-built to have this inventory of what is the software that is supposed to be there, right? Let's quit trying to enumerate the bad stuff. That's a fool's errand. Let's focus on these allow lists. What is supposed to be there? And the cool thing about FACT is if everyone can contribute to it, right? Here's the software that's supposed to be on a piece of equipment. You can upload it to FACT, and it becomes this big community initiative, and that's what I'm hoping for. That's why I'm proud to be an advocate for FACT. So let's look at the second big win for OSI Soft and our customers. The second one is this idea that there is a life cycle involved with software, and as unexpected as it might be, because the paradigm in the enterprise world is that software just auto updates. It knows to go out and get its version and check it so often and nag you about updates. In the OT world and the operational side, most software does not do that. And that includes OSI Soft products. So what that means is customer really, if you counted the mouse clicks it would take them to really try to understand is there a newer version for this piece of software? It's kind of embarrassing, actually. Compared to where the IT world is, we have a lot of work to do. And we found that FACT was an easy way to add that visibility. So while you're checking the hash, oh, is this the right file? Oh, by the way, this isn't really the right one you should be using. You should really be looking for a newer version. Or worse yet, is this one's out of support, dude. You should not be using it. So we have a one-stop shopping that is available to everyone. So I think this is a great service as well. Now, ideally, maybe in the future, this won't be so necessary, but today it is. All right. what's the third quick win? Well, you saw this in Eric's slide. And rest assured, you can get a score of 10. FACT is not one of these systems that makes it impossible to get a good score. And for the lower scores, let's face it, they get your attention, right? Skull and crossbones, red, it's all kind of there. It jumps out at you. But we saw it in the survey, right? People want to know, they want an easier way to know if the software they're using has vulnerabilities in it. And it's great that FACT has that. Our experience is that most of our customers aren't entirely there yet on the ICS side. The update frequency still follows the hardware refresh pattern. And for application software and embedded software, updating just still isn't that current. But at least the information is there for the people that do have those programs, and the people that are moving forward say, hey, you know, let's update our components more often. Maybe it's once a year, maybe it's every shutdown, but now this tool is out there. The important thing about this is there's still no malware here. So I want to be very clear that just because there's a score of 2.9 doesn't mean that you're in imminent danger, right? This is still software that has not got embedded malware. And again, I would say the first step for our industry from a supply chain perspective is we need to root out the malware, right? We can do that. Once we get there, let's start tackling other parts of the supply chain problem, which may be vulnerabilities, but remote access is actually higher on my list. All right, what's the fourth quick win? For us, it was this notion that other people could contribute to the FACT system. We can discover uploads from the wild. FACT will tell us about that. So in a perfect world, every package that OSIsoft ever built would be uploaded into a trust anchor like FACT. We've been in business for 40 years, and it's just not realistic to think that that's going to happen. So because FACT allows everyone to contribute and can alert us when there are contributions, we can see what's of interest to the community, and the whole ecosystem benefits from it. So if there is a problem in something that gets uploaded externally, we can act on it, and that's really useful to me. All right, the last one. This one is that graph picture that Eric showed. So one of the things that is not always obvious is where is a DLL used across ICS. I used to run into Art Mannion a lot at S4, and I think a lot of Art's gray hair from his activities at CERT were trying to track down what packages are vulnerable when there's a component vulnerability. So I'm here to tell you that even within our software, we have interdependencies between our products. So in this graph database, it's very simple to ask FACT, where else does this DLL show up? And that's that 57 relationships on here. So a very useful tool. So those are the 5 ways that we've been using FACT at OSIsoft to get some quick wins. I hope you enjoyed those. The summary here is really, this is about transparency, like Patrick was saying. We need the entire ecosystem for ICS software to be more transparent. What is supposed to be there? Anything else we can assume shouldn't be there. This idea of it being problematic for customers to know what's the right version, is the software good. We have to find more tools to solve that, and Fact is a great start at that. And I'm really upbeat as to all the possibilities that this kind of a service can enable. There's been a lot of work initiative done by NTIA on the software bill of materials, and Fact is well aligned with that. It decomposes these packages right down to the file level, and we have found some really interesting pieces that we just really didn't know to look that low in the stack. But things like, oh, you know, this setup kit was actually using digital signing that has since been revoked. I think we all remember that Google and other suppliers decided to ban some old VeriSign signatures, right? Well, we had some old products that were still using that setup technology. We probably wouldn't have found it without Fact. So it was a nice surprise, a nice find. So all in all, supply chain security is a monster problem, and knowing how far you can go without breaking the bank is hard. We see Fact as a great start where everyone can benefit from everyone else's effort. We're very pleased at OSIsoft to contribute to this kind of a service. And I want to close with a thank you for all of you attending, for the speakers that came before me. You really laid the right foundation for this, but also from our founder, Dr. Kennedy, to leave you with this nugget. I think it's very apropos for the Fact system is as more and more people use data, that data becomes more valuable. And my ask for you, my call to action is start using Fact. We'll all get more value if you do. Thank you.
Thank you, Brian. Great summary points, and I love the closing quote. I think it hits home and carries through on a lot of the points that were brought up earlier in everyone's presentations. So in the remaining time, I'd like to transition now to the Q&A portion of our day today. We're going to address the questions that are coming in, and I know there's been a lot of activity in the Q&A window already. So please feel free to keep submitting questions. We've got about a little under 10 minutes left that we'll try and address those. You can send them in here in the platform with Q&A, or you can also send them across the social channels using hashtag ADOLUS_ICS, that's ADOLUS_ICS. And several of you have asked the question, and yes, the content from today's session will be made available at the conclusion of the conference. So fear not, we will get this into your hands. And in the event that time doesn't permit us to get through all the questions that have been submitted, we're going to carry the conversation over to the social channels. So you can watch for those to be addressed live on Twitter. So let's kick off a question then. Maybe I'll go with kind of a round robin here in the last several minutes of the session. Patrick, let me start with you. Let's talk about resources for a second. If you have no additional budget or resources, what's the most effective thing that you can do in terms of supply chain security to get started today?
I think Brian answered that question already. Use Fact. Yeah, I think it's since it is effectively, free to at least test your stuff through the website. It's probably the most benefit you could get for $0 and little effort, right? So if you had hardly any time and zero money, that would probably be the best thing you could do.
Excellent. Thank you.
Yeah.
Thank you for the tool as well. So here's an interesting one. Megan, a question for you. What should someone do if they suspect they've received a counterfeit product?
Sure. So I think that the first place they could start, number one, they could always call kind of customer support from the vendor. Secondly, if they have an account manager that they regularly work with, that person could probably get them a question pretty quickly. But there are some materials online that can help you in detecting fraudulent labeling. You see a lot of the use of holographic labels by some vendors, and this is becoming more sophisticated. So there are some quick kind of Google checks you can do if you suspect that maybe within your supply chain you've been handed or you have accidentally bought a fraudulent product from a dealer who maybe unfortunately got it within their supply chain, or maybe the dealer wasn't authorized. But always first make sure that you're buying from authorized dealers.
That's good insight. Thank you. The question came in here, Eric. How is FACT different from an antivirus service or a vulnerability detection service like BlackDuck? Can you comment on that?
Yeah, sure. So those are great services, and the problem we saw is that there's just so many of these services and they're so distributed. So what FACT's really trying to do is build a community to share. What's the antivirus community think about this package? So we're not an antivirus package. We use antivirus packages. We're not a vulnerability detection service. We use vulnerability detection service. Good example is we work a lot with a company called Refirm Labs that tears Linux packages, embedded Linux packages apart and finds vulnerabilities. So it's really, that's what FACT's trying to do, is just get all the data in one spot. So as Dr. Kennedy says, more people can use it, and then more value can be made of that data.
Seems to be a tremendous amount of conversation over the past couple of years, even now, around trust. How transparent does a company need to be considered trusted? If you want to address that one, Pat.
I would say, I don't know, this one's a challenge because it gets into the questions around, are you showing your competitors your secret proprietary information or your secret sauce? Are you giving away the farm by being too transparent? I think there are ways to do this, and I think it comes down to, if something has been already tested and it's already known. For example, we could use something like FACT to validate what we already know. Now it comes down to validating anything that new. So the transparency centers would allow people to come in, kick the tires, look at things in a way that gives them assurance. How deep do you go? I mean, as deep as the market requires, unfortunately. So that's not an easy answer to come up with. It's not like, oh, here, you're good if you go this far. I think it depends on, how far is the market demanding it? And the market is often going to get pushed by political or geopolitical or other cultural influences. So that answer is never going to be a static answer in any sense. So the transparency centers, I think, are something that are good for organizations to stand up. Part of what it does is it helps, it first, creates trust, right? It implicitly creates trust just by the nature of the fact that you're trying to be transparent. But you can, by being transparent, you show what you're doing to be transparent, right? So the transparency in transparency is what gives you that additional value. So if someone says they've got a transparency center, but they're not really showing anything, that gives you a higher or lower degree of trust in their ability or their dedication or diligence around transparency. Does that make sense? I know that's a bit of an inception answer, but the concept of transparency is valid for so many reasons that I think Schneier and many others have said it. Transparency is the best thing for security because others can vet it, others can see it. So it's going to have to go as deep as you possibly can without giving away the farm eventually. I think is the best answer I can give to that.
No, I can appreciate that. Thank you for commenting. Eric, looks like you wanted to add something.
Yeah, I was going to say that was one of the really interesting things we saw early on in the project is no vendor wants to be transparent about their source code for obvious reasons. So you really do have to pick carefully what it is you want to expose. And I think, exposing things like your certificates and your component hashes and things like that is probably a pretty good, reasonable middle ground. I mean, nobody wants to be submitting their actual firmware or software to a third party and then losing control of it. So I think that's one of the things we really have to balance here. And say, as Patrick says, it's really about what is a transparency to be useful without giving away the farm, and I think we're trying to do that.
Here's a question. Megan, go ahead before I move on.
I was just going to tie off on this statement. I think it dovetails into what Eric and Patrick are saying, but you shouldn't care about what people say. You should care about what they do. And I've overheard some conversations where I've seen people say, gosh, did you see that vendor over there? They just had, 70 vulnerabilities come out in the past year or something. And I'm like, well, they could have been externally reported or internally reported, but the fact that someone is willing to transparently follow a coordinated vulnerability disclosure process means that you should probably trust them, because the number one foundation that I learned from physical security is that you can't protect what you don't know about. And tying off with the FACT program and the points that Patrick brought up earlier, don't fall into this flawed logic that because vendors or other people are describing their vulnerabilities or security flaws, that's exactly what you want to see. You want to see that positive transparency, and again, it doesn't matter what people say, it matters what they do. And disclosing these artifacts and doing it in a transparent way and using a program like FACT, that's exactly where the industry needs to be headed.
Excellent point. Brian, please.
And then I think there's one other aspect about determining if something's trustworthy or not. And at some point, every company will approach this with their own kind of DNA. But I think the path is easier for companies that do leverage third-party attestations of some sort. To go it alone entirely is very hard. I think that was part of Patrick's presentation. It can be done, but very, very expensive. So in short, these tool makers that are building binary analysis or dynamic analysis, static analysis, those are third-party attestations in a more automated form. Certification labs are pretty heavy, but those are valuable as well. So there's a spectrum of independent assurance activities that, as those accumulate, the trustworthiness of a piece of software or hardware increases. It would be another aspect I'd like to throw to the party here.
Excellent. Well, thank you all for the comments and the perspective on this. And I think that brings us to the bottom of the hour. I know there were a couple comments that came in here at the 11th hour around the FACT session. I think you had commented on this as well, Eric. I mean, there's a question about, is there a fee to implied on this to access the link? So we'll address that one then shortly here. And I wanted to take a moment to thank everyone for joining us at today's session. And I'd like to invite you to visit our events page for the up and coming educational webcast brought to you by IIoT World, including our Industrial Cybersecurity Day, which is going to take place on October 22nd. You'll find additional information on that at iiot-world.com, which is our website. And special thanks to our sponsor today, Adolis, for this educational session, and to our speakers, Patrick, Eric, Brian, and Megan. You did an outstanding job, covered a lot of material today, so thank you all for sharing. If you have a suggestion on a topic or otherwise, we always welcome feedback, so drop us a note and let us know. If you like what you heard today, we'd invite you to subscribe to our newsletter, YouTube channels, and follow us on Twitter at IIoT_world. This concludes our program for today. Thank you for joining us.
Thank you.